good to go? The mic working? Okay, great. Hello, everyone. My name is Tomasz Drwięga. I work at Parity Technologies. And today I would like to tell you a little bit more about the stuff that myself and my team are working on, which is bridges. But first, let me start about the second part of the title of my talk, so Polkadot. What is Polkadot? I guess we are all here in this cross-chain salon, and we can all agree that single-chain future is not going to happen. We won't have a single blockchain that's going to rule them all. Rather, we will have multiple independent blockchains that have some means of communication. And they are somehow connected, can exchange information, but they are separate blockchains. And Polkadot is our take how this multi-chain future can actually look like. So Polkadot is a protocol that allows cross-chain communication and also shared security for multiple independent blockchains. The really cool thing about these blockchains is that we really don't care what these blockchains do, how they handle their state transition function, like what unique features these blockchains have. So they don't have to be homogeneous. Rather, each of them can be very unique and very suited for the task that it's supposed to solve. So for instance, one of these chains might be more like a Bitcoin chain, might be using UTXO model, and another chain might be more like Ethereum, allowing EVM, smart contract execution, and yet another chains might look even differently. Ideally, everything that happens on the relay chain, which is this overarching blockchain, kind of bubbling down the shared security and coordinating these other blockchains, there would be nothing happening there because all of the interactions would be happening on Parachains. Yeah, and in the Polkadot white paper, we also envision how existing networks with a separate consensus could be connected to the whole ecosystem as well through bridges. And building smart contracts is super hard. So you can also imagine that building a separate blockchain that would be connected to this network is even harder. This is why we have a framework to build these blockchains called Substrate that gives you an easy way to kind of mix and match a bunch of components that you want your blockchain to have and plug it into Polkadot ecosystem in the future. So Polkadot is all about interoperability. To join the ecosystem, there are a couple of different ways of doing that. So it depends on how much coupling with the rest of the ecosystem you want to have. So if you join as a parachain, so one of these blockchains connected directly to the relay chain, you have to use Polkadot consensus, but you get very quick interactions with the rest of the ecosystem through this cross-chain messaging system. There is this idea of having parathreads, which are a little bit less coupled. This is a work in progress. And then kind of on the very other side of the spectrum, we have bridges, which means the blockchain that you build is completely separate from Polkadot, but you have a connection through a bridge to the ecosystem. And I roughly split these bridges into two categories. One are all of these kind of third-party bridges where you actually have some kind of an intermediary, be it either a multi-sig or another kind of validator set that acts on the other blockchain behalf, or something that I call a native or fully trustless bridge, where the intermediary is actually not necessary, but rather we are able to verify the other consensus system natively. I'm going to go into details what that means in a second. So what bridges are actually about? We have two separate chains or consensus systems. And the idea of the bridge is to figure out that something happened on this other remote consensus system or a chain. So there is some event, and we would like to understand that this event actually happened, right? So for instance, someone locked their tokens on Ethereum chain, and now we want to know on Polkadot that, yes, these tokens are indeed locked, so we can take some action. For instance, we can mint a wrapped token on a Polkadot ecosystem. And there are really cool things that people are working on, for instance, optimistic bridges, which means let's assume that this event happened because someone said so, unless we get a fraud proof and someone proves to us that this indeed didn't happen. And these kind of bridges are really nice because they come from these technical challenges of building these real native trustless bridges where we verify that indeed something happened, because verifying that something happened is usually quite expensive. So yeah, as I said, with the trustless bridges, and these are the bridges that I am the most interested about, the idea is that you provide a cryptographic proof of this event happening. So this might be a Merkle proof of transaction receipts, or a Patricia Merkle tree proof that some state entry has a particular value. And these proofs are usually large, usually hard to verify, so I'm also really interested in upcoming developments here, where we can use some more succinct proofs, for instance, zero-knowledge proofs, which means they are much smaller and much cheaper to verify, but they give exactly the same cryptographic security assumptions. So what these events are, I already gave some examples, because usually when people think about bridges, they think, oh, I want to transfer assets, or I want to transfer tokens from one chain to another. But this is only one particular application that can be running on a bridge, because ideally we would let these two chains exchange arbitrary messages. So for instance, to allow smart contracts calls from one chain to another chain. And there are a couple of challenges here. One of them, and this was mentioned a couple of times already on this event and on FCC, the messaging format and like standardization of how we express the intent of the user when we go across the bridge is something that would be really good to talk about and to experiment with. So what kind of bridges are planned for Polkadot? So these bridges are already in development, and the first bridge I want to mention is a bridge to Bitcoin network. It's a collateral-based bridge, which means that it's trustless through this economic incentive mechanism. So it's much more, if you cheat, you're going to lose a lot of money. That's pretty much the bottom line of this. It's based on a paper called Xclaim, and it implements this Xclaim protocol. And the team called Interlay is working on this bridge implementation, and my team is just supporting them, but they are pretty good. They don't need that much support. And this bridge is very close to getting deployed, and it's pretty much like technically completed, and there's just a thing how to deploy that bridge now. Another bridge that is being built for Polkadot is a bridge between Ethereum main network and Polkadot. So this is a fully trustless bridge, which means that if we go from the Ethereum side to Polkadot side, we are actually verifying the entire header chain of blocks created on Ethereum, which means that for every block, we need to verify that it's building on the canonical chain, and also that the proof of work is correct. And there is an interesting challenge there, because verifying proof of work requires you to either create this very large file called DAG, or to compute elements of that DAG in flight. And this is not really feasible to do on-chain, neither of this. And there is a really nice solution or a trick how we can make it possible. So we can pre-compute these DAG files, we can Merkleize these DAG files, and then whenever we verify proof of work, we actually provide also Merkle proofs of the items that are required for this proof of work verification. Other side of the bridge, so when we go from Polkadot to Ethereum, that means that we need a Solidity smart contract that is able to verify Polkadot consensus and to follow Polkadot consensus. So essentially, a light client of Polkadot within a Solidity smart contract. And Polkadot is using a consensus algorithm for finality called GrandPA. And GrandPA means we have around 1,000 validators. They need to produce signatures, and they need to pick blocks that they actually think are final. And verifying 1,000 signatures in an Ethereum smart contract is also quite challenging and probably prohibitively expensive, especially that the crypto used by Polkadot is not really native to Ethereum. So we have come up with idea of another finality gadget called beefy that I'm going to go into more details in a second, which is suited exactly to make this bridge possible. So it's using Ethereum native cryptography, and there's a really nice interactive verification protocol that allows us to like bring down the number of signatures we need to verify from like 1,000 to around 10. And I hope Alistair from Web3 Foundation will be there, and maybe he's going to tell a little bit more about this. And this bridge is being developed by a team called Snowfork, and they are also doing a really good job here. And another, sorry. And another bridge that we plan is a bridge between Polkadot, so the main network kind of instantiation of the Polkadot protocol, and a Kusama network, which is a wild cousin of Polkadot. So it's a chaos, we call it a chaos net. It's basically a test net with valuable tokens to make sure that all of the mechanism designs we have are working. This means bridging two major relay chains, so pretty much bridging two ecosystems made of parachains. And the idea is that the on-chain entities will be able to control tokens or act on their own behalf on this other ecosystem. I've briefly mentioned Substrate, which is this framework to build not only parachains that can become Polkadot elements, but also separate blockchains, standalone blockchains. So the bridge between Kusama and Polkadot is actually an example of a more generic bridge that my team is building, which is bridging two arbitrary substrate-based chains. The components that we have in our repository can be divided into these three layers. The first one is this on-chain light client implementation. Second layer is about passing messages and delivering messages. And the third layer is about actually like the bridge application, I would say. So from the first layer, you can mix and match components. So we support Ethereum proof of authority right now. So you can build a bridge by picking a bunch of components from our repository and bridging two substrate-based chains, or in that case, Ethereum-based chain. Okay, I don't want to go too much into the details. So the messaging palette allows sequential and parallel delivery of the messages. So you can queue up messages, and you are sure that these messages will arrive exactly at the same order. It might not be that important for asset transfers, but we are speaking about like a very generic arbitrary messages bridge. And then for many applications, this will be important to know that some things happen exactly in the same order as the other side meant that. Currently, for the message payload, we use something that is very substrate specific. So it's scale encoded calls of the other chain. But we hope in the future we're going to use the same format that is designed for cross-parachain communication to kind of blur the difference between speaking to another parachain and speaking to another chain that is just bridged with the network. OK, I don't have that much time left, so I'm going to skip a bunch of slides, I think. I've briefly mentioned beefy a few slides ago. So yeah, this is this additional gadget for efficient bridging. And it will allow customizable crypto to make it really cheap to build these on-chain light clients in the future. Another cool thing is Merkle mountain ranges, which allows us to reduce the payload of this on-chain light required by this on-chain light client from entire headers to something that is just like a 32 bits hash of some accumulative data structure called Merkle mountain range. Another thing that we plan for substrate-based chains is to overhaul the frame system events mechanism. I know this is like probably very specific for you guys, but if you know what I'm talking about, like please come by and talk to me. Your input is greatly valued here. And another thing that is on our agenda for the upcoming year is to, as I said, like kind of blur the difference between speaking to another parachain or speaking to another component in the same parachain and speaking to another consensus system across the bridge, which will really enable this kind of cross-chain applications to be possible. Yeah, that's it. Thank you. Are there any questions? Do we have time for questions? Yeah. Cross-chain calls atomically. That's a very tricky question, because the whole point of kind of splitting the one chain into multiple independent chains is you don't want to synchronize them on what they are doing, but rather you want them to kind of proceed at their own pace independently. And if you want to do atomic operations in such setup, this becomes very hard because you would need to kind of pause another chain and wait for this other chain to actually like process the message. So while I don't think it's going to be supported natively in terms of like your contract execution or transaction execution actually stops and waits for this other chain to process that message. But I think it's possible to come up with a very cool schemes how you can actually do something and then asynchronously like resume whatever you were doing, right? It's more challenging because the execution of your transaction is going to split between multiple blocks. But with substrate-based chains, it's possible to kind of pay the gas cost of that execution upfront and then have that thing kind of progress with upcoming blocks when you receive responses. Does that answer a question? Okay, one more.
How many projects are migrating from other blockchains onto Polkadot? I know Polkadot has an Ethereum equivalent. So how many of these projects are migrating onto Polkadot?
So I'm kind of very much a heads-down developer working on tech, as you can probably notice. I know some of the numbers. So what we have right now, we have 6 parachains running on Kusama. There were 5 auctions. I think there were actually like 13 teams competing to get this 5 parachain slots. And these are teams that are ready to get deployed on Kusama. We have a Builders program, and Web3 Foundation has grants program. And I think there are around like 100 projects that are part of this program and kind of working on their tech to get deployed on Polkadot. Cool, thank you. Sorry?
All the DeFi blue chips from Ethereum will be on Moonbeam. As you heard it here first from Peter Morick on the beanbag in the center of the room. Let's go ahead and give Tomasz another round of applause. Thank you, Tomasz, one of the nicest people in crypto. And thank you, Polkadot. As you guys can probably see, Polkadot was also a sponsor of this. Some things that are interesting that I find about Polkadot. The YOLO atmosphere of Kusama was actually pretty inspiring, and like just to see a testnet turn into a meme in and of itself is actually a very interesting like social experiment to watch, and I think that's something that I like. Reason why I like crypto in a lot of ways is because we can just do stuff like that. So I think we're gonna get like really properly started here. I'm glad to see all these folks here, and I think we're gonna do a cross-chain identity panel. That's not the schedule. I turned like as if I was going to point at a schedule. And yeah, we're going to be going until, what is it, 5 p.m. is like the end of this. Pitches starting at 2 p.m. and we have a lot of great panels and lunch and just people in general. We have lunch for about 200, so we have like 400 people registered for this thing, so get your food as quickly as you can. But thank you, and I'm going to introduce Yazinator here, who's going to start this cross-chain identity panel. Who? Oh, yeah. Oh, thank you.
Thank you. Thank you. All right, so I'm really excited about this panel because I think that decentralized identity is super important for everything you're trying to do in blockchain.